Okay, so this video is the Unit 3C classwork video. Um, and so let's just work our way through it. It'll be the same lesson that we had in class, basically. Um, so number one, we've talked about that the angles in a triangle add up to 180, but we've never actually proven it before. And now that we started parallel line stuff, we actually can prove it. So let's take a look. Notice the given is just that you have some triangle ABC, which really means you can draw any triangle you want. And I'll draw one that looks kind of like this. And make that a little bit straighter. So here's my A, B, C. Okay. And then what I'm going to do is, this is sort of the trick to proving that this has 180 degrees. There's one other thing you know that adds up to 180, and that's if you have a straight angle, the angles that form that, like if I had something like this plus this is going to be 180. So what I'm going to do is create a straight angle that will come in handy. And so I'm going to erase this temporarily and then I'll put it back. But you might remember from the homework, there was a problem that said if you have a line and a point not on that line, then you can draw exactly one line through this point that is parallel to the original line. So now if I put this back, there's our triangle, and now we have the red line and BC are parallel to each other. And in order to label the red line, I'm going to just make up a new point on it and call it D. Okay, and then to make things a little bit easier, I'll add in some angles here. 1, 2, 3, 4, 5. 5 main angles in this picture. So let's start the proof. Now, I'm going to kind of fudge a couple of reasons in the proof. I'm not going to ask you to do this on a test. So we started with we had a triangle ABC. That's given. And then what we did was we forced AD to be parallel to BC. We made the line AD parallel to BC. And that's kind of given, but what I'm going to say is we made AD parallel to BC because we were allowed to draw one line through A that's parallel to BC. So that's not really a very good reason, but I'm going to just say for now, that's fine. Okay. Now, we know that we have to pretend that we don't know that a triangle adds up to 180 yet. And in this picture, another way of saying MA plus MB plus MC equals 180, in our picture, that'd be 2, 4, and 5. So I'm going to write below it, really what we're trying to prove right now is M2 plus M4 plus M5 equals 180. That's our goal now. Okay? Well, if you notice, now that we have parallel lines, we can do all the things that parallel lines give us, like parallel lines give corresponding angles congruent, stuff like that. Right? And there were 5 of them: alternate interior angles, alternate exterior angles, those were congruent, and then the same side types were supplementary. Well, if you notice right here, here's angle, well, actually, before I do that, let's look at these 3 things. Right? Those 3 angles all together, M1 plus M2 plus M3, those end up being 180. And I'm going to fudge this one too, but we've got 3 angles next to each other add up to form the big angle. That's the angle addition postulate. Now really the angle addition postulate is you're only supposed to take 2 angles at a time, but you could combine 1 and 2 and then say, okay, now I'll take the 1 and 2 and add it to 3. So I'm just going to put here, it's like the 3 angle version. Okay? So let me erase this so it's not in the way. Now if you look at the parallel lines, notice this equation has a 1 in it, but the equation I'm aiming for doesn't have a 1 in it. And this equation also has a 3 in it, but the equation I'm aiming for doesn't have a 3 in it. The 2 is good. The 2 is already there. So the goal is to try and replace the 1 with something and replace the 3 with something. And if you look at it, here's angle 1, and it turns out 1 and 4 are going to be congruent to each other. Because if I extend these lines here, here's 1 and here's 4, right? And if I drew them over on the side, 1 and 4, I know the top and bottom are parallel, and 1 and 4 end up being alternate interior angles. Alternate because they're on different sides of the transversal, and interior because they're between the two main lines. So I now know that angle 1 and angle 4 are the same measurement. So I'll say M1 equals M4. And the reason is because I had parallel lines already, and they gave me alternate interior angles that are congruent. And similarly, if you look at the other side, so let's see, I'll just use a highlighter here. If you look at the other side, and I extend these lines a little bit, here's angle 3, and here's angle 5. And if I were to draw those by themselves, there's the top, there's the bottom, here's that slanted line. 3 is here, and 5 is there, and these lines are already parallel. So 3 and 5 are also alternate interior angles. So I'm just going to cram that into the same step here. Measurement of 3 equals measurement of 5. Okay? So it turns out now that instead of 1, I can write 4. So I can plug in the 4 here. And instead of 3, I can write 5. So I can plug in the 5 right there. So now I end up with M4 plus M2 plus M5 equals 180. And that's because I just used some substitution. And now if you think about it, well, 4 plus 2 plus 5 equals 180. This one is also 4 plus 2 plus 5 equals 180. So now we're done. Okay? All right, so let's take a look at the next one, number 2. So number 2 is kind of tricky the first time you see it, but after you've done a problem like this, usually they're not too bad. So now the key to this problem, I'm going to give you some info about angles, like M1 equals M4, and then you look at the diagram and figure out if that helps you show that any particular lines are parallel to each other. So, and then the lines are all labeled along here, right? N, J, K, U, and T. So now, when you think about the different types of angles, like alternate exterior angles, the way that you form them all is you have a couple of lines, and then you have one that crosses them. So anytime I'm talking about these special types of angles we've talked about in class, you need 3 lines that form the 2 main angles. 3 lines, right? That's the key. So let's take a look at M1 equals M4. So if I trace out the lines that form M1, or angle 1, it's this one and this one. And if I trace out the ones that contain angle 4, it's this one again and this one. And here's angle 1 and here's angle 4, and I know they're congruent. So the nice thing about doing it on the computer here is I can just scroll that down, and if you look at it, well, 1 and 4 are corresponding angles. And I know that if I have corresponding angles that are congruent, they give me parallel lines. And in this case, the lines are U and T. So I would write here, U is parallel to T because what are they? Corresponding angles that are congruent give parallel lines. Okay? So let's take a look at 6 and 4. So if I trace out 6, it uses line T and line J. And if I trace out, what's the other one? Angle 4, it also uses T and it uses K. And I know that they're equal in measurement. So if I take this and slide it over to the side here, here's 6 and here's 4, and you can see that they're equal to each other, and they form that Z shape. And remember, the Z shape are alternate interior angles. So this one, those lines are J and K. So I can say J is parallel to K because alternate interior angles that are congruent give me parallel lines. Okay, so let's take a look at the next one. The next one's a little bit trickier because there are 3 angles involved. But it turns out if you look at 2 and 3, you can combine them to form one angle there. So think of it like this. 2 and 3 put together equals 5. Here's 5, right? And if I draw the lines that form 2 and 3 put together, it's U and K. And then 5 uses K and T. And so now if I slide this down, well, you can kind of tell they're in corresponding locations, and they're congruent. So I can say U is parallel to T. Actually, it's the same exact reason as A. So I'm just going to do this because I can. Copy. Paste. Oh, great. Of course, it doesn't go where I want it to. So let me move that up. Right there. Oh, that's in the wrong spot, isn't it? Right there. Okay, so let's look at 2 plus 3 plus 8 equals 180. So again, 2 and 3 put together, it's probably a good idea to think of it like this. 2 and 3 put together plus 8 equals 180. So the lines that form 8 are U and J, and the lines that form 2 and 3 are U and K. And if I slide this down, you can tell that these are same side interior angles, and they add up to 180, so they're supplementary. So in this one, these lines were J and K. So I'm going to say J is parallel to K because same side interior angles that are supplementary give me parallel lines. Okay, and that's a valid reason. If it said congruent, then this wouldn't work. Those don't give you parallel lines. Okay, let's look at the next one. I'll switch colors here. 1 and 7. Well, here's angle 1, formed by U and K. And if you look at it, angle 7 is the same deal, U and K again. They are congruent, but they're not congruent because of parallel lines, or they don't give you any parallel lines. They're just congruent because vertical angles are congruent. So this one, no parallel lines result. And remember, we needed 3 lines at a time to get any of these special types of angles. This only uses 2, so that doesn't do anything for you. Okay? Let's look at 5 and 6 are supplementary. So 5 is formed by T and K, and 6 is formed by T and J. Whoop. So here's 5 and here's 6, and we know that they add up to 180. You might be able to tell this without even sliding it over. Well, those are same side interior again, and they're supplementary. So in this case, it's J and K are going to be my parallel lines. So J is parallel to K because same side interior angles are supplementary. Give you parallel lines. And then the last one says 4 and 5 are supplementary. Well, here's 4, here's 5, and they're formed only by 2 lines. So that's not going to lead you to any parallel lines. So no parallel lines result. Okay, let's take a look at the next problem. So 3 is related to a homework problem from the last set. And it says if 2 angles of one triangle are congruent to 2 angles of another, what can you determine about the third angles? Okay, well, let me draw 2 triangles that have the same size angles. So I'll draw one that looks like this, and I'll draw a smaller one that looks like that. So if I know this angle and this angle are the same, and that angle and that angle are the same, well, then I could say, well, this triangle adds up to 180, this triangle adds up to 180. And if I get rid of the 2 angles from both of them, I'm left with the third angles having to be equal to each other, right? So these guys end up being the same. So the third angles are also congruent. So you can use that in a proof. If 2 angles of one triangle are congruent to 2 angles of another triangle, then the third angles are congruent. That's sort of a lot to write in a proof. So if you wanted a shortcut, I'll let you get away with doing this. So if 2 angles of one triangle are congruent to two angles of another triangle, then you get the third angles are congruent. I'd be okay if you use that in a proof, all right, so that you don't have to write out the whole thing. So let's look at 4. So number 4, it says prove the following using a 2-column format. AB is parallel to CD, AD is parallel to BC, and then we want to prove that angle A down here and angle C are congruent to each other. Okay, I'm going to do something to make our lives a little bit easier. We're going to end up referring to some angles, so I'm going to number them. 1, 2, 3, 4. I'm not going to bother numbering 5 here and 6 there because I can just get away with calling this angle angle A and this one angle C. Okay, so let's take a look. AB is parallel to CD. Let's start with that. So AB parallel to CD is given. So now what I'm going to do is I'm going to come over here and mark AB parallel to CD in my picture. So then, I'm not going to list the second given yet. I'm going to look at what these parallel lines do for me. So they're my parallel lines, and I'll extend them a little bit. And here's a transversal. Right? So if I were looking at angle 1 here and angle 4 there, right, and these lines are parallel already, then you could say 1 and 4 are alternate interior angles. And I know that since my lines are parallel, 1 and 4 are going to be congruent to each other. Okay? So, let me move this back. So now I've got angle 1 is congruent to angle 4 because parallel lines give me alternate interior angles that are congruent. Okay, let me get rid of the green stuff here. Add that back. Okay, so right now we have 1's congruent to 4 and those parallel lines. Okay, so let's take a look at the next given. AD is parallel to BC. That's given. So in that one, I've got that this line is parallel to this line. So notice right here, here's another Z shape that uses those two new parallel lines. So if I've got angle 2 here and angle 3 there, if I draw it like right here, here's 2, here's 3, I already know these guys are parallel. And if you can't remember what the Z shape does for you, it is alternate interior. Just extend the lines a little bit, and it'll be easier to tell that these are alternate interior. So in this step, I'm going to say, all right, so angle 2 is congruent to angle 3 because, well, I had parallel lines in step 3, and they gave me alternate interior angles that were congruent in step 4. Okay, now it turns out, let me label that, so these angles are congruent. So it turns out that's enough to finish your proof. Step 5 can be angle A is congruent to angle C, right? And if you think about it, well, I've got these two angles in the triangle on the left congruent to these two angles on the triangle on the right, so I can use this reason right here. I have two angles in one triangle, same as two angles in another, so the third angles are the same. So I'll just draw that in. Two angles of one triangle match up with two angles of a second triangle, so the third angles match up. Okay? All right. And then the last problem, all right, so the last problem here, it's solving for these angles, and let's just work our way through this chunk. If this angle is 136, has to be 130 because they're vertical angles. I know 5 and 130 add up to 180, so 5 will end up being 50 and 7 will end up being 50. And then, if you look over here, I've got parallel lines right there. So I'm going to move what I drew out of the way, right? So whatever this angle is, that goes with its corresponding partner up here. So this one was 130, so this one's 130. So now I know 2 is 130. So 3 is 130. 4 has to be 50, and 1 has to be 50. So let me label those in. 50, 130, 130, and 50. So now we just have 8 and 9 left. Remember, this one's 50. Okay. So if you look at 8, 8's formed by those two. And up here there's a little 90 right there, formed by these two lines. And the top and the bottom are parallel. So let me slide this over. Right there. You can ignore the black. 8 is down here. Well, this angle up here and this angle 8 are corresponding angles. So whatever the top one is, the bottom one is also. So this one's got to be 90 degrees. So 8 is 90. Well, you can do the same sort of thing right here, because these guys are parallel. So you could say, well, 90, this 90 corresponds with that angle. So this angle's 90, which goes with that angle right there. So now I have a 90 in this corner. I already knew 5 was 50, and then I got a little triangle right here. So if you add up to 180, angle 9 ends up being 40 degrees. Okay, I hope that helps some.